your question from home here, the audio may be a bit distorted. You should have in your chemistry booklet this formation of ions and ionic compounds. So, what you've indicated is you can go from the nucleus here, you can set up your Bohr diagram, and this gets you your Lewis dot. So, what is sulfur going to do now? Well, if you look up in your textbook, you will discover that right at the top of the tile for sulfur. So let's say in your textbook, it's a bit slow doing this at home. There's the letter S, right? I'm not drawing too well here. There's a -2 in the top corner. That is the valence for sulfur. That's what goes in the charge column. Um, so what's going to happen with sulfur here? Well, it's got 6 out of 8 filled. So this means it's going to try to find 2 electrons to fill in there. There are 2 parking spots. So we could add 2 actual electrons in there, which would give us a charge of -2. And that's what's written right down here. Okay. Magnesium is going to do the reverse. Now, what I shouldn't have done here is draw the empties. That's not normal for the metals. I'm the only teacher that draws the empties. So I'll take them away. Magnesium has a nearly empty shell. So if possible, it will ditch these 2 electrons and park them right over here in sulfur. So magnesium will remove those. So he's going to go like this. And if he gets a chance, he will empty his shell and send these electrons elsewhere. That's taking away a negative. Okay? Removing a negative is the same as becoming positive. Let me show you if you aren't certain. A normal neutral atom, let's say, is this. I'm not going to draw, well, actually, I could draw 12, couldn't I? 5, 6, 7, 8, 9, 10, 11, 12. Here's magnesium. Yep. And it will have, what would be this here? 12 electrons. Trick. It's only 11. Don't tell anyone. Okay. Now, what happens if we add these up? 12 positives and 12 negatives are 0. But if I go ahead and I take away 2 of the negatives like this, then I'm left with 2 spare positives. So magnesium is going to become +2 when it throws away 2. And that's what's written in the top of magnesium's tile. If you go to your textbook, it'll have Mg. Look at that, drawing with my mouse. It'll have magnesium. And it's how to make my writing look like a kindergartner. Do it with a mouse. That's why magnesium says +2. Where is it vague? Where it gets vague is at the halfway point. So let's suppose we picked another element, like carbon. Carbon has exactly 4 filled and 4 empty. So I'm going to make some pretend little shells here. 1. Oh, got it. Not transparent selection. Give me a second here. Hello. There we go. Oh dear. What a mess now. So carbon has... I saw your question tonight, so this is the quickest way I could find of answering it for you. Carbon has 8 spaces, just like the others. Not as pretty as what I can do in class, but you get the idea. And so it's got 4 full. So when it has 4 filled and 4 empty, should you pick up 4 or lose 4? The answer is it's complicated. So there's no charge for carbon. We don't know what it's going to do. We have to tell you. The other ones that are tough are the noble gases like helium. All the noble gases get totally full shells, and they will do nothing. So this is easy to decide the charge, providing it's more than half full or less than half full. If it's exactly half full, just put a dash. If it's totally full, just put a dash. And this page here pretty well explains it. I've also attached a video link showing me doing these things right out to the end. So hopefully that answers your question, which is a really good one, as opposed to what do I do? You actually had a specific question. So well done.